Hello Physics Nation, my name is Albert and today we are in an exercise of twerk. So our scenario is a basketball ball and we are going to spin that basketball ball as shown like in this picture. So well, for get things to spin we need to apply a twerk, that is newtons per meter, for things to rotate. So we have given the force that we apply. We have the moment of inertia of a spherical shell, that is this one, and well, the torque, because we are spinning counterclockwise, will be positive, and the equation of the torque is I times alpha, that is moment of inertia times angular acceleration, and then the torque is force times radius. So well, let's get into it. So as shown in this picture, we are going to have two radius, because is how we spin the ball. So we will have from here, and from here to here. And they will have the same direction, so they will add, as shown in here. So first, the radius in here is 5 centimeters. We need meters. So with unit conversion, 5 centimeters is 0.05 meters. So let's find the torque. Torque is force times radius. So 7 times 0.05 is 0.35 newtons per meter, and times 2 will be 0.7 newtons meter. That will be the torque, the summatory of the torque. Obviously we are ignoring the friction in the finger, because with the friction in the finger, well, things can get complicated. Then we have to find the moment of inertia. The moment of inertia is 2/3 mr squared. Our mass is 600 grams, that is 0.6 kilograms. And then our radius, we gotta use the radius, the big radius, not this radius. So we use 0.23 meters, and then you substitute in here and you will get 0.02116. That will be the moment of inertia. And well, it would be kilograms and meter squared. And then you substitute in the equation of torque. So solve for alpha, and we get 33 radians per second squared. That will be our acceleration. So because there is no friction, when we spin the basketball ball, it will spin, it will have this acceleration, and it will be at 33 radians per second all the time. Because there is no more or less acceleration. It's just that. And then, well, we can find the frequency, that is cycles per second. So it's saying how much times is it spinning in 1 second. So the thing is that 1 lap is 6.14 radians, and we are just simplifying the motion like in a circle. So if we have 33 radians per second in, and we divide by 6.4 radians, that is 1 cycle, we will have 5.37 earths. So that means that the ball will spin 5.37 times in 1 second. And then period. Period is the inverse of frequency, and it tells us how long does it take for do a cycle. So we divide 1 over 5.37 and you got 0.18 seconds is the seconds that you take for do 1 cycle. And then, well, we can find a lot of stuff, like we can find the angular kinetic energy, that is 1/2 I double J squared, so the moment of inertia and the angular velocity. So if you substitute, you will have 11.52 joules. Then we can find angular momentum. Angular momentum is I times double J, and if you substitute and you get this, and then, well, because it's a circular motion, every circular motion has a tangential and a centripetal acceleration, a tangential velocity, I mean. So well, for convert angular to linear, you gotta multiply by radius. So this will be the angular velocity, and then centripetal acceleration would be v2 over r. That is how fast it's moving to the center. That would be this. And also, this 7.59 meters per second means, how do I get out to here? Means that here the basketball ball is spinning, but in this moment this is going like this way. So that velocity would be 7 meters per second. That's the tangential velocity. And that'll do it.